Today is Wednesday, March the 18th, 2020, and this is the variable frequency setup for this AC controller for GE RMA number 20013, where we're showing the setup. We have 140 volts AC at 60 Hertz. That's our input. We have the board with a maximum sync high of 10 volts. And because the AC input is 140, the corresponding output, according to your oscilloscope, it's about 135, 136 volts. You can see the notches there. We have a board that it's enabled. That's why this signal is high with respect to its ground. And the board does not have a phase loss. That's why this signal here, the magenta, or actually the violet signal, it's high with respect also to its ground. These are normal conditions. We have a latching circuit here that if we were to encounter a phase loss condition, this will latch, or if the board is inhibited either as a result of a phase loss condition or because if we manually inhibit the board, that will also latch, and this will have to be reset. We have the same, in this case we're only drawing a few milliamps. We're running a lamp load. And here we have a running oscilloscope. First thing I'm going to do is I'm going to inhibit the board. So when we inhibit, we've inhibited. Notice that this shows that the board is inhibited. And we inhibit it. We don't have any output, but yet we don't have a phase loss. That's why this is still high. And of course here we don't have an output. Let's go ahead and bring it in, enable. So we are enabled. This is back up again. Now we have an output. And here, the only way to clear this is coming back and clearing it. So again, this is all working under normal conditions. Now, in the next step, we're going to phase loss. And when we phase loss, we're going to check that we have a latching circuit here. Because we have a phase loss detection, we're also going to inhibit, and we'll take a look at the corresponding output. So let's go ahead. So we have the board inhibited, and with a phase loss detection, we've latched the two circuits, and we come here and we don't have an output because we're inhibited. The board is inhibited because of a phase loss, and the phase loss now has triggered. And of course we don't have an output. Let's go ahead and bring it back. So again, the only way to clear this is resetting my latching circuit. And the last thing that I'm going to do is, this is how the board was run for over 36 hours. We will be looking at the phase loss condition to verify that the board never inhibited. We will set it up as a single trigger, and this oscilloscope will be let on for hours and hours until we either trigger an inhibit condition, more importantly a phase loss condition, that's our triggering channel, or until we get one of these LEDs latching. So this is basically the setup, and unless we had a faulty condition like the condition reported out in the field where we have a phase loss condition, let's go ahead and induce a phase loss. Even if we let it go and clear it, it's back again, we will notice that this would have latched it, and our oscilloscope would have got this phase loss detection circuit. The last thing we're going to do is we're going to take a couple of shots of the circuit itself, and we're going to do it. Remember, this is with a generator, and we're going to do that again with 480 from the utility, and we'll point out some differences. This is the end of this video.